Good evening, everyone. We'll start with today's session. So today we are covering two topics, piping codes and standards and pipe material specification and manufacturing. Mr. Ashwin is our trainer for the day. So you can mute your mics and you can ask your questions at last of the session. Also, you will be having the assessment of today's session in two parts. One assessment will be on Monday and the second part of the assessment will be on Tuesday. Monday, you won't be having any training sessions. I request Ashwin to carry forward with the training. Thank you.
Good evening, all. I will share my screen. Hope my screen is visible to you all. Okay, so yesterday's continuation. Today I'm going to take the topic piping codes and standards and the little brief about material specification, piping material specification. This is the agenda of today's training. Okay, so today's training content is as follows. It's a codes and standards and specifications. It's a basic definition of all of the three things. Then I'm going to the what is the requirement of using the codes and what are the codes we are using in the piping systems and what are the standards we are following in piping designing and the difference between what is piping and the pipeline, then how to calculate the pipe wall thickness for one process condition, then what is piping material specifications, what are the engineering deliverables are prepared by the piping teams, then what is the exact organization setup for the piping engineering team in an organization or the engineering consultancy. Okay, so these are the parts today we are going to see and going into the session. So, what is codes? Codes is a set of rules. It was developed by some standard
Ashwin,
organization.
uh,
Yeah,
Ashwin, your screen is not visible, Ashwin.
not visible to you?
No, it's not visible. Can you reshare once again?
Sure, sure. Now it's fine.
Yes, now it's okay.
Okay. Okay, so now we are going to see about codes. What is codes? Means the code is a set of rules. It was developed by the standard organizations and institutes over the world. They have the own set of engineers and the manufacturers of if it's representative of that organization, and they have done many researches and they have done many experiences in their past previous projects. So based on that experience and research outcomes, they have developed some set of rules to follow in the oil and gas industries. Okay, so that kind of details and information are gathered together and provided as a codes. So in that codes, what we can extract from that codes. So it is give the requirement, means it gives the solution for the design and what kind of rules we have followed for the fabrications, what kind of materials we have to choose, what are the testing ideas and the testing preparations we need to do for that installations and inspection, how to inspect that pipe in the regular manner. These are all the details are available in the piping codes. While you are developing design or engineering for an facility or the plant, in that time you should follow the codes, and because you cannot overcome or you cannot avoid the rules which are already developed in the developed by the organizations. It should be followed. What exactly written in the code, it should be followed while you are designing. So that is code, and in sometimes we need some additional details. For example, if you are designing any one of the pipe, what is the size of the pipe, what is the material of the pipe, how it going to be erected, and how it going to be painted, and how it going to be tested. These are all the details. Everything is available in the codes, but some dimensional details we need, right? So for the 6-inch pipe, what is the standard size should be followed. These kind of details we can extract from the standards. Okay, so that is the difference between the codes and the standards. So now we are going to see what is standard. Now, here, the piping standards, it will give the application of design and the construction rules. And it will also give the dimensional values of the flanges, elbows, T's, valves, and the various piping components. Okay, so the dimensional and the pressure related details are everything available in the standards. How to how we need to design, how we need to fabricate, those kind of details available in the codes, and the dimensional and the pressure related details are available in the standards. Okay, so while you are doing on design and engineering project, you should follow the code. International codes, there are many international codes are there, I will mention in future, but those kind of codes should be followed while you are designing. It cannot be neglected, or it cannot be overcome the rules which are mentioned in that particular code book. You should follow all the things. If you are not following, then you cannot claim your insurance. It should not, it will be the violation of the international codes as well as the local body authorizations. Okay. So, what is the responsibility of the engineer, who is going to become a design engineer, who is going to become a piping design engineer? He should aware of all the codes and standards. Okay, so he is well versed in the codes and standards. How to, we cannot able to memorize all the things in the codes and standards, right? But how to refer, where we can get the exact details. These kind of idea, it should be with that particular engineer. There are multiple type of standards are there, related to the materials, related to the dimensions, related to the pipe components, different types of weldings, different types of testing, different types of painting technologies and the painting methods. For everything we have the separate standards. So the engineer who is responsible for the design, he should aware of all the standards and codes, and he should well practiced in how to refer the code books and the standards. Okay, then who develop these codes and standard books? Okay, that is the organization or the committees. Okay, they have the representatives from the various industries, manufacturers, and the professional groups, government agencies, insurance companies. It's a set of group of people. They have developed some rules for maintaining globally while doing the design and activity. So that committee peoples are the main responsible for maintaining and updating the code books based on the recent technological development, research, experience we have, and from the previous problems. And these are all the details should be captured. And for each and every year, they will revise the code books, and they will update something in the code books and standard books. Okay, so while you are doing the design, the recent technology should be applied in that particular design, because we should follow the recent version of the code book. Now what are the recent changes they have done, they will highlight it properly in the document. We should go through that, and in the future designs, in the further designs, we should follow the same things while our designing. Fine. So what kind of details the piping code will give us, will give to us, right? So it will give the how to make the design, how to choose the material, how we are going to fabricate the piping components, Then how we are going to install the piping system. Once you install, how you prepare for the testing of the piping system. Once you test, then the regular inspection, while you are working, the regular inspection should be carried out. So what is the periodic time to maintain for the one inspection to the another inspection? So these kind of all the details are available in the piping codes. It should be followed for the each and every oil and gas plant projects. Okay. Then what are the additional details we can get it from over there? So the piping code can provide the decent criteria for the material of construction. What are the materials we can choose for the particular fluid we are handling? Okay. And what is the maximum allowable stress for the particular piping material, and what are the loads it can be withstand, the thermal loads or the other additional means the shear loads. There are many kind of loads will be applicable for the piping systems. So these kind of load values and the working stress value we can get it from the piping codes. Okay. Then based on the code advice, we can estimate the wall thickness for the particular pipe based on the process requirement. Okay. So the piping wall thickness, how the formula for the piping wall thickness, it's already available in the code book. Today we are going to see how to calculate the pipe wall thickness for the particular process conditions. We are going to see, so these details also available in the code book. Then how the material will behave for the particular process conditions, everything was already clearly explained in the code book. uh, so then, okay, for the external pressures, apart from that, we can get the values of external and the internal pressure, dead weight, seismic loads, live loads, and the thermal expansion and contraction. These are all the values. While you are designing one piping system based on the internal and the external properties, so the piping system will affect from the internal pressure and the external pressure, and the dead weight of the piping system is going to be act in the piping supports. The seismic loads, due to the earthquakes or the earth movements, we are feeding some loads from the seismic, and as well as the live loads also, and wind loads also we can able to extract from the piping codes, as well as the thermal expansion and contractions. Due to the temperature increase, the piping components may be expanded. In that time, we need to allow the expansion in the piping material. Otherwise, the piping will be getting failure. The piping system will be getting failure. So these are loads while you are designing the piping design. You should keep in your mind, because if you are not allowing these loads in your pipe, you are not considering these loads in your piping system, after installation it may get failure. So how, what is the percentage, what is the criteria we have to follow, and what is the medium we should follow? These are all the details clearly available in the piping codes. Okay. So, and apart from that, we can get the details for the non-standard fittings. So the standard fittings details are available in the standards. Pipe standards means ASME 6.1. There are many material standards are there. The dimensional standards are there. We can the standard sizes of the pipes available in those standards. But some of the other things, some of non-standard fittings like for example, if you are using one T, reducing T, if you are using, its size will be 6 class 3, means 6-inch class 3-inch. It's a reducing T. If you are using less than that, if you are using 6 class 2-inch, it is not readily available in the market because it is not a standard size. So for that kind of fittings, but you really need that kind of reduction in the sizes in the while doing the branch connection. So in that time, what we can do, we have to design the special fitting. So it is called as the non-standard fitting. How we need to design that? What are the parameters we have to consideration while you are designing that non-standard fittings? So these are all the details also available in the piping codes. Here, now we have seen about piping codes. What are the details we are getting from the piping codes? What the code book says, who developed that code books? Everything is available what are the details we can extract from the code books. These are all details we have seen. Right now we are going into the piping standards. Okay, so piping standards, the standards will give us the design criteria and rules for the individual piping components. That is important thing, because in the piping system is a combination of multiple components, right? So not only the pipe will be the piping system. There are multiple fittings over there, the elbows will be there, T will be there, valves will be there, gasket, flanges, bolts, nuts, and everything will be there. Okay, for each and every component, we should follow some standards, because if you are going to design the international uh, uh, in the international market, because if you are designing some flanges and giving the flange data sheet to the manufacturer, the flange size should be same from all the manufacturers. Otherwise, you cannot able to purchase. Sorry. Okay, fine. So the piping components. The main purpose of the standard is to standardize the dimension globally. That is the main function. Okay, if we are going to purchase one flange, first of all you need to prepare one data sheet for the flange. Okay, then the specification for the flanges we need to develop. These all the details are same for the, these are the details already developed and tabularized in the piping standard books. Okay, in the piping particular piping standard. While you are preparing the data sheet, your only concern is we are going to pick the exact piping material and the piping dimensional standards. You need to mention what kind of dimension standard should be followed, what kind of pressure standard should be followed. These two details, if you are defining, those kind of flanges available globally. Where if you are ordering some flanges from India, you can get the same size. If you are ordering the same thing in the Gulf, you also get the same size of flanges. So the standardizing the piping components dimensions is the main motto for following the piping standards. Okay, so there are two major concepts in the standards. One is dimension, another one is pressure and temperature based standards. Okay, so the dimensional standards will give us the dimensional parameters of each and every piping component. So the dimension standards, the purpose of this to ensure the same dimension for similar components. Okay, so it was manufactured in the different origins of the world. So, but the dimension of the same dimension of each and every piping components will be same if you are ordering in the correct sizes. Okay, so that is the main purpose for the dimension standards. And the second one, the pressure and temperature is going to be withstand. Okay, so what is the maximum pressure limit for the particular piping component, what is the maximum temperature limit for the piping component. These details also already standardized, and we have to refer the particular correct piping standard for that. If you are mentioning the correct piping standard for the material and the dimensions, it will be enough to purchase a correct thing. If you can get the particular piping component over the world, because the same standard should be followed for the all the design and engineering consultancies and all the design and engineering companies, as well as the oil operators also. Okay, so these are all the benefits for codes and standards, because it develops the direction of thinking for all us. We can think in the similar way, because everyone is going to do the same kind of engineering activity. Everyone is going to design the same kind of piping components, so the similarity in the thought will be the same. Because otherwise, if you are following the different kind of fittings, it may lead to the any accident or any hazards. If you are following the same thing we followed in the previous experience, then it will reduce the probability of the hazard making. So that is the thing. We are standardizing the piping components design and dimensions and pressure and temperature ratings. Okay. Then it ensures the safety I have already explained to you. Then if you are design something as per the code and standard, the local government always have the same kind of set of rules with them. And if you are following any international code and standard, then the local body will automatically give the approval for the particular design. And it will give the similarity in the engineering materials, right? So if you are following the same kind of design, wherever the same points we have already discussed, the dimensions and the materials, everything is same, then you can get the prices product from all kind of valid origins, right? That is the main motto. Then it minimizes the mismatching also, and it helps to reduce the cost also. These are the things we are getting benefited from the codes and standards. Apart from that, if you are having the good well standardized details with you, you can easily communicate with other disciplines also, because each and every time you do not need to give the dimension of each and every piping component. If we are developing your design based on the piping standards, the other discipline people also can refer the same standard while they are designing. Because if you are doing some piping component and you are going to install some instrument on it, the instrumentation people don't come and ask you what is the flange size you are following, what is the valve size you are following. Those kind of details, for the each and every details, they are not depending with the piping team. So they can directly refer the piping codes and standards. They know the dimension of the particular component, they will do it with their self. So this is the main thing. While you are designing as an engineer in the piping, you can get a benefit by use of codes and standards. Now, so what are the major piping codes we are following here? So, American Society of Mechanical Engineers, they have established the current international standard pressure for the pressure piping code. The pressure piping code is called B31. In 31, there are multiple subdivisions are there. Okay. For example, if you're using B31.1 for the power piping, power piping stands for the steam generation unit, the power generation unit, wherever the people are handling with the high pressure steam, those kind of piping is called as the power piping. Then B31.3, it's for the process piping. Our major oil and gas refineries, plants, terminals, everything is coming under this section only. So the majorly most of the people are following B31.3 for the piping design. Then B31.4, it's for the pipelines. It's not for the piping, it's for the hydrocarbon transportation piping. Then B31.5, it's for the refrigeration piping and heat transfer components. Then 31.8 for gas transportation and distribution piping systems. 31.9 for building services and piping, and 31.11 for slurry transportation piping system. These slurry transportation piping system is mainly in the steel industries we are following. These kind of pipings we are available in the steel industries, and the fertilizers also we are following that slurry transportation piping systems. So these are all the details about each and every piping codes I have described over here. So B31.1, power piping. So the main purpose of this piping code is design and construction of power piping of electrical power generation stations, industrial and institutional plants, geothermal heating systems, and central and district heating and cooling systems. So where for these kind of facilities, we are going to use B31.1 piping code for the piping design. Okay, so for ASME B31.3, it's for the process piping. This code is mainly used for to construct, design and means for the design and construction for petroleum refineries, chemical plant, pharmaceutical, food industries, textiles, paper, paint, cryogenic, and any process related plants and terminals. These are all coming under B31.3. So this is the main most oftenly we are using B31.3 for all our piping designs. Okay, so B31.4, it is a design for the pipeline. Okay, so this code is following while you are designing the transportation pipeline of liquids in between, only for the liquids here, for the between the plants, terminals, and the pumping regulation stations. So these liquids are the crude oil, condensate, and the natural gasoline, liquefied petroleum gas, because it's a semi mixed phase only. It's not only for the gas; it's a mixed phase, because your the LPG will be transported in the liquid stage only, not in that gaseous stage. Then carbon dioxide in the liquid alcohol and liquid petroleum products. So, for example, the pipeline from upstream to midstream or downstream. This is the flow, because the pipeline's major idea is while you are extracting the crude oil from the surface level, from the underground level to surface level, then the pipeline will be started over from the wellhead, from the oil well to the nearby storage area or nearby refinery area. We need to transported through the pipelines only. Some other mediums also there, like barges are there, railways or tankers. These are all available. If we are transporting through the pipes, then it will be called as the pipeline only. Okay, from the wellhead to the nearby storage, or the wellhead to the any other gathering stations or the terminals, anywhere. If you are getting out from your fencing area or the battery limit, it is called as a pipeline. Okay, so ASME B31.5, it's a refrigeration piping. It's majorly used in the hatchback system, heat ventilation and air conditioning systems. For each and every heat recovery units, these kind of piping systems will be followed. Then ASME B31.8 is a gas transportation and distribution piping systems. The same thing which we have followed in the 31.4, there we are handling with the liquid phase, here we are handling with the gas transportations. Okay. Then for B31.9, so the building services of piping. So for the buildings and the industrial and the commercial buildings, for the residency building, we will follow some fire water lines or the foam lines. These are all for the under the plumbing and drainage lines, for each and everything. There we are not going to use different size of pipes. It's a simple design. It's a simple design for the residency. It's simple design for the industrial. For that B31.9 we are following. Okay. For B31.11, it's typically for the slurry services. Mainly, it's for the non-hazardous slurry services. Okay, so such as coal, mineral ores, and other solids. Majorly, it was used in the fertilizers and steel industries. Uh, these are the piping codes which are developed by the American Society of Mechanical Engineers. So what is the similarity in that? Previously, we have seen around 8 to 9 piping codes. So what is the similarity in that? So each and every code having the calculation for the pipe wall thickness and the inspection and the testing. So these are the things similar for all the codes. So how to estimate the pipe wall thickness, how to inspect the piping components and the pipe fittings, everything, how we are going to test. These are the details are similar, but where these piping codes are differ is that particular factor for safety we have considered.
Ashwin, sorry for the inconvenience, guys. Please give us a moment.
Okay. So
Ashwin, can you share your screen? I think you got disconnected in between.
One sec. I will share the screen.
Yeah, yeah.
Is it visible now?
Yes, it is visible. Also, participants, please share your questions in the link because when you share it in the chat, there is a chance of missing that out. So please post it in the link that I've shared. Yes, Ashwin, you can continue.
Okay, okay. I think the last part I have discussed is similarity and difference in the piping codes. So what are the similarity is pipe wall thickness calculation and the inspection and the testing. These are all the similarities. The difference in the piping systems is the factor of safety we are following for the setting the allowable limit and the applications where we are going to use. These are all the difference in the piping codes which we have discussed earlier. Now we are going to see about the international standards for piping. So what are the standards are available in the internationally for the piping systems? Okay, the first one is ASME standards. So as American Society of Mechanical Engineering standards. The second one API. They are the institute. They have also developed some standards for piping systems. Then ASTM. American Society of Testing Materials. They are the institute. They have also developed some piping standards. Then AWS, American Welding Society, American Waterworks and Associations, AWWA, and MSSSP, Manufacturer Standardization Society, and Special Practices. So these are all the standards we are following internationally for the piping design. Okay, so now I am going to explain the different standards are developed by the each institute under each organizations. Okay, so ASME standards for piping components or fittings. So these are all the designs. So the below standards are used for the design and dimension and the manufacturing processes. Okay. So from if you are referring this standard, you may get for example here you can see B16.11 ASME B16.11 one is there. Okay. It is for cast iron flanges and flange and fittings. If you are referring that particular standard, you may get all the information about the cast iron flanges, like what is the outer diameter, what is the face thickness, what is the end thickness, and a number of for each and every sizes, for each and every pressure rating, how many bolts will be going to be used. So what is the size of the bolt and the nut, so these what is the materials, what is the maximum pressure it can be withstand. So these all the details are available about the cast iron flange. If you are referring B16.1, this is the design related things and the dimension related things. Then the second part is about manufacturing process, how we are going to manufacture that based on the forged operations. If you are doing the manufacturing, what are the set of rules you have to follow. So these details also available in that particular standard ASME 16.1. In the similar way, for all the pipe fittings in the different classes, for the, here the class means the pressure rating. So for the different pressure ratings and the different temperature conditions, how the equipment means how the particular fitting should be designed, what is the dimension available, what is the standard dimension available in the globally, and what how you have to manufacture that particular pipe fitting. So these are the details are available in that ASME standards. So here you can see some of the ASME standards are listed. Among those, B16.5 for flange and flange fittings. This is the one we are using commonly for the flanges, and all other standards I have listed. Hope you have this PPT for your uh, examination and the assessment things. You can just refer all the piping codes and which piping code representing what kind of pipe fittings details. Okay, this is the long around 20 to 30 standards that I have listed over there. You can just have a overlook while you're having the free time. Okay, now we have seen about ASME standards. Now the same kind of standards for the piping system was developed by American Petroleum Institute, AP Institute also. Okay, so these AP Institute having set of standards with them. It is also I'm going to speak about the pipe sizes and the pipeline walls and the testing of the walls and means welded tanks storage. What is the details we need to follow, what are the design requirement, what are the dimension requirement, and what are the manufacturing requirement we should follow for the tanks and oil and gas separators. These are all the equipment related things, not for the piping. Then pressure safety valve and check valves, valve inspection and testing. So these are all the standards they have developed for the particular engineering and piping and design, piping and mechanical design things. Okay, not only for the piping, it's related to the mechanical static things also they have developed. And here I have listed some AP standards along with that specification and detailing. You can just have a look after this training program. And then this is for the American Society of Testing Materials. Okay, so the first two things from the ASME and the API, you can get the design related things, dimension related things, and the manufacturing related things. In the ASTM, American Society of Testing Materials, you can get the details how we are going to test. This is the first thing. Okay, what kind of testing you have to done while you are manufacturing the fittings or the pipes or piping components. So the first thing is the testing. The second one, the testing of the materials also. So you are choosing the material like carbon steel. If you are choosing, you have to maintain the material composition which is specified in the particular standard. You have to follow the material composition. You have to meet the all the mechanical properties like yield, stress and allowable stress and yield point, elasticity, everything for the each and every mechanical properties you should follow as per the details which we have provided in the, which are already described in the American Society of Testing Materials. The testing procedures also explained in that particular standard. So you have to follow what kind of testings we have to done. So the testing mediums for the testing purpose, what are the set points, what are the to-do list, everything is available in the particular standard. You should follow all the things while you are developing the pipe fittings or the pipes as per the ASTM standards. Okay, so here I have listed some of the ASTM standards for your reference. You may go through after these sessions. Here the abbreviations LTCS means low temperature carbon steels, LAS means low alloy steels. So these are all the common abbreviations. Once you are familiar with the things, you can easily get it over there. So these are the standards available for welding, means welding operations. How we are going to do the welding procedures, or what are the different types of weldings over there, which is suitable for the particular operations, the qualification record for the welder, the training record for the welder. After the welding, how we are going to testing that particular welding weld joints, and how we are periodically maintain those particular weld points. So all the details and the standards and the regulations are available in these particular particular 4 welding standards. You can refer it was developed by American Welding Society. So these are all the standards. You can just have a overlook if you have the copies of it. Otherwise, once you join if any one organization in the technical library, you can get these standards for your reference, because these are the standards may not be available in the internet. It was already purchased and keep for each and every design and consultancy teams. Once you have joined in any one of the company, you may easily get these reference copies while you are doing the particular design. So apart from piping, we have many codes for other equipments also. Here I have listed some of the codes for your reference. ASME B, sorry, ASME section 1 for the power boilers, ASME section 2 for the material specifications. Here for all the materials they have tested, they have listed our mechanical properties of each material, the composition of each material, and the maximum allowable pressure, maximum allowable temperature, and many all other material related things are available in the material specifications. Not only for the standard materials, it will be available for the tubes also, it will be available for welding rods, and each and every materials and invented till today, it was standardized in that particular section 2. So ASME section 2 is the important thing to choose the materials. Okay, so then ASME section 4 for the heating boilers, ASME section 5 for the NDT testing and examinations, non-destructive examinations, ASME 8 for pressure vessels. It have two different divisions, ASME section 8 division 1 and section 8 division 2. These are for the pressure vessel designing. Okay, so ASME section 9 for welding and bracing qualifications, and section 10 for fiberglass reinforced plastic and pressure vessels. So these are all the different codes available for the mechanical components also, mechanical and materials also. Okay, okay, now I am going to explain about what is piping and pipeline. This is the picture I have posted over here from a recent site visit. Okay, it was done in Muscat location. Here you can see one fencing, right? And some color differences also you can observe from this photo. Okay, so once the piping is entered, the pipe is entered into the fencing, the color was in white color, right? In the outside it was colored over around brown. It's a nature color of CS. Okay, so these are all the differences, the color differences they have separated, like uh, from that flange joint, from that flange joint the piping battery limit is getting started. Okay, once the piping is when the pipe is coming from any other facilities without any fencing area, once the pipe is getting enter into the fencing area, then it is called as piping. Okay, outside of the fencing it is called as the pipeline. Okay, so for example you can imagine something. One storage vessel is located some location A, it was located inside the fencing area. Okay, and another one storage tank is located in location B. It was around 10-kilometer distance. Okay. Now from the store location A to B, we need to transfer that particular fluid. Okay. So we are installing two pumps in the location A. Okay. So the location A, the fluid was getting from the storage tanks and it was pumped by the pump and it is traveled to the location B. Okay, so the interconnection between these two locations is pipe, is it was developed by the piping system. Okay, so now consider there are two fencing areas, one is location A fencing area and another one is location B fencing area. The piping design which are all developed inside that fencing in location A and as well as location B, it is followed as per B31.3. It's for the process piping. all the piping components and the pipe thickness and everything was followed as per piping process piping B31.3. So it is called as piping system. Okay, once the pipe is means getting away means it's exited from the particular fencing area. From that point, here you can see outside of the fencing the color was different, right? So from this point to next 10 kilometer away from that particular location, those pipe routing is called as pipeline. So it will be followed ASME 31.4 or 31.8, it based on the liquid. If it is handling with a liquid hydrocarbon liquids, it will be 31.4. If it is a gas, then it will be 31.8. So these are all the difference for the piping and the pipeline. So as I have already explained to you, the, the different codes for the 31.3 and 31.4 and 31.8, for each and every piping codes some similarities are there. The calculation for the pipe wall thickness and the testing and the inspection, these are all the same, but the factor of safety we have going to consider. For the piping, the maximum allowable stress will be 1.5 times, 1.3 to 1.5 times we are normally considering. Okay, for the pipeline it will be 1.2 times. Okay, it's not in the factor of safety, 1.2 times of its descent pressure, 1.3 to 5 times of its descent pressure. These are the difference. Okay, so the safety of factor we have considered, it may be differ for the different piping codes. It is a major difference for the piping and pipeline. So the pipes available inside the fencing is called as piping, outside the fencing is called as pipeline. Okay, so these are the major difference for the pipeline and the piping. So here they have listed the first point is series of straight pipe welded together for a long distance. Okay, so in the piping we are going to use multiple fitting components, like we are using flanges, we will use uh, elbows, we will use T, we will use reducers. For many piping components are used in the piping networks, but considering the pipeline, the main pipes are only jointed together with the weld joints only. There are no more another other special components it's introduced in the pipeline. You cannot able to see in some specific locations for the underground connections or some thermal expansion joints. In those locations only the majorly the pipe fittings may be available. For all rest of the all locations, all the straight pipes are welded together and for the long distance. Okay, then the second one I will show some photos after this slide. It will be clear for you. Then for the underground and above ground and underwater such as subsea pipeline. So the underground services, it may be the pipeline may be available for the underground, above ground and the underwater also. Most of the piping is available in the above ground only. Very few locations, if necessarily needed, if you are any road crossing or something, in that time only the piping will be going under the ground. Most of the locations you can see the piping will be in the above ground only. Okay, so mostly the pipeline will be in the larger sizes to compare to the piping. For the piping you can see the pipe sizes from half an inch to maximum 36 inch. Here I have put as 80 inch. Half an inch to maximum 36 to 40 inch diameter piping you can see basically inside the plants and the facilities. Okay, so use of pipe fittings are limited, as I have already discussed in the first point. The pipe fittings usage is limited in the pipeline. For the piping we are using many kind of pipe fittings. For each and every pipe fitting we have developed many piping standards as well. Okay, so in the pipeline most probably you cannot see any equipments, because if you are installing any equipment then it will be coming under any fencing area. Okay, you need to provide some fencing to protect that. So if the piping is coming pipe is coming inside the fencing, then it converted into the piping system, it's not called as the pipeline. So most probably and most oftenly the pipeline system doesn't have any equipments. Okay, but in the piping you can have many equipments will be there, because the major pipe routings are connected through the nozzles with the equipments. If you're considering one tank, the tank should have one minimum requirement of inlet line and the outlet line, right? Those lines are connected with the piping network only, not with the pipeline. Okay, the outside the fencing it will be considered as 31.4 or 31.8 design code. Now, before that, the particular area for the till the particular fencing limit, it will be followed as B31.3. Then, as I have already told, the safety factor 1.25 times of design pressure was followed for the pipeline in the liquid, for the liquid pipeline transportation lines, for 1.25 to 1.5 times. It depends on the design requirement. Times of design pressure for gas pipelines, it's a major allowable limit. Okay, so for the piping, it the hydro test pressure is calculated by multiplying, means the hydro test pressure was 1.25 times, and the maximum allowable limit will be till 1.5 times of the actual pressure, operating pressure. Okay, then for the pipeline we are following the design code 31.4 and 31.8. For the piping, the most often 31.3 and 31.1. These are all the piping codes we are following. These are the some of the difference I have listed over here. Once you are getting familiarized into the piping things, then you may get a huge idea about what is the difference between the piping and pipeline, what are the factors they have additionally considered for the pipeline design and for the piping design, uh, the soil properties and everything. The deliverables which we are developing for the pipeline is entirely different with compare of piping engineering. Okay, because the elevation drawings we need to prepare for the pipeline, we need to give the elevation profile, we need to do surge analysis and many things we will perform for the pipeline. You know, for the piping system it will be different things. So the design wise, pipeline and piping having huge differences. Once you are getting into the things, then you will let you know all the design and engineering related things which are considered for the pipeline design and the piping design. Okay. Now I will show some dimension details. So how the dimension was annotated for the piping. Okay. So in the pipe, I have projected some cross section of the pipes here. Okay. In the first image, you can see the NPS. The NPS is nominal pipe size. From the half an inch to 12 inch, the nominal pipe size is in between the ID and the OD. Okay, it's a center distance you can call. So the NPS, nominal pipe size, it was in the center from the OD to ID. It was in all the standards for the pipes, for example 36.11. You may see this is the detail. In some locations they will follow the dimension annotation as 4 inch. uh, in some locations they will mention as not for the 4 inch, it's from the 112 NPS. So the NPS means the nominal pipes is in the mm. If you're 25 NPS means it will be the 1 inch pipe. Okay, so in the similar thing, the NPS is the up to the 12 inch. The NPS is the dimension in between the OD and ID. So what is OD? The outer dia you can see in the picture. It was in the second image, and in the third image the ID is internal diameter. So OD and ID it's pretty clear for us. For the NPS, it's interstage between, means interstage dimension between the OD and ID. Okay, so this is the wall thickness. It's a difference between the OD and ID. It is a wall thickness. These four annotations for up to 12 inch pipe sizes only. Okay, for above 14 inch means above 12 inch, what is the size and the criteria we have followed? The NPS and the OD are same for above 12 inch pipes. Okay, NPS means nominal pipe size, and the OD are same for the above 14-inch pipe, and the OD and ID are similar as for 12 inch, for below 12 inch and above 12 inch are the same. For the OD and ID and wall thickness annotations are same. Only the difference is between the NPS. Okay, you have to keep in your mind while you are saying some dimensional values in millimeter. In that time, you should keep in your mind what is NPS. The NPS for 12 inch and below 12 inch pipes, it enter between OD and ID. If it is above 12 inch, it should be the OD is equal to the NPS. The outer diameter of the pipe will be the nominal pipe size for the above 12 inch pipes. Okay, these are the piping dimension details you should keep in your mind while you are designing. Okay, now we are going to see how to calculate the pipe wall thickness. Okay, before you are estimating the pipe wall thickness, these are all the details and the inputs you record from other discipline people. Okay, the first one is the main considerations. Any plans for mainly designed for the 20 years at 7,200 cycles. One cycle means 1 day. So the total 20 years equal to 20 into 360. So around 7,200 cycles we are following as a design life. This is the first criteria, is the first consideration. The second one, the corrosion allowance of the piping material. Okay, so what is the corrosion allowance we record? These details will be provided by the process discipline people. The chemical engineering process discipline engineers will give the corrosion allowance to us. These detail will be available in the PNID and the line sizes. Okay. Most probably for the pipeline, they have described the corrosion allowance in the PNID. For the piping, in the line list, you may get the details about the corrosion allowances. What is the corrosion allowance we should follow? These details is provided by the process department. Then the material engineer will give the pipe material. We are carbon steel material or stainless steel material. What are the material? It's a non-metallic pipes. So what is the suggested material for this particular fluid service? It will be suggested by the material engineer for our design considerations. Okay, then the manufacturing type also, it will be recommended by the process discipline, and based on the piping material discipline, they have the decision is coming from the piping material discipline, but the interaction between for the choosing the perfect correct manufacturing process, it was developed by process and the piping material teams. Both the teams combinedly discuss and they will conclude the piping manufacturing methods for the project requirement. Then the line size, what is the size we should follow? So these line size we can get it from the P and ID based on the line numbering is there. From the line number we may get those details. Then the pressure and temperature for the lines, it will be available in the line list. The line list document was prepared by the process discipline. Then pressure and temperature for the different lines. Okay, the pressure and temperature limit, what is the design pressure and the design temperature, what is operating pressure and operating temperature. These all the details are available in the line list. The line list document was prepared by process discipline engineers. Okay, then the fluid nature and the fluid characteristics, it was they will develop a document called process flow diagram. In that process flow diagram, multiple stream numbers they will give based on the fluid behavior. Okay, so for the each and every fluid stream number, they will prepare one document called heat mass and balance. In that heat mass and balance document, you may get the fluid characteristics and the behavior of the fluid. So if it is in the toxic nature, it was clearly explained in that particular HMB. Based on the HMB document, you can get the corrosive and toxic nature. That document also was prepared by the process discipline team. Then the common consideration will be for the carbon steel or low alloy steel or low temperature carbon steel, the corrosion allowance will be taken 3 mm in general. If the fluid is less corrosive, the corrosion allowance may be differ from 1.5 mm to 3 mm. It based on the design requirement. We cannot assure that the process discipline will confirm that. Okay. For the stainless steel pipes, 0 mm of liquid because it won't react with any fluid. So the corrosion will be zero for the stainless steel materials, almost zero, not a zero, almost zero. So for stainless steels, we have considered the corrosion allowance as zero. For the carbon steel and other materials, we have followed from 1.5 mm to 3 mm of corrosion allowance based on the design requirement. Okay. Then the mill tolerance also. The mill tolerance will be available only for the seamless pipe, not for the welded pipes. Only for the seamless pipe, we have considered mill tolerance. The mill tolerance range will be 12.5% of the estimated thickness value. So these are all the basic considerations and input requirement while we are performing the pipe wall thickness calculation. Okay. So now we are going to proceed for one example pipe wall thickness calculation. So these are all the details I have considered. The first detail I have considered is the material of construction of the pipe is carbon steel. The grade is A106 grade B. Okay. Here the A106 grade B is available, right? If you are following the material specification, material code, ASME section 2, you can get all the mechanical and material properties of this particular grade. All the details will be available in section 2, ASME section 2. Oh, then I have considered here the nominal pipe size is 6 inch of the particular line. This detail I can get it from the P&ID while I am doing the actual process project design. In that time, this 6 inch will be determined by the process discipline and it was annotated in the P&ID. From the P&ID I can extract this value. Then the manufacturing type of the pipe. Seamless pipe for DFW and ERW is here. Here I have considered the seamless pipe, the seamless manufacturing type of the pipe. So in the seamless pipe, there are no welding will be available, but in the EFW and ERW, you can see the welded pipes because the plate was bended. The plate will be bent as in a circular shape. So the connection point will be welded by the technology of EFW or ERW. In the seamless pipe, there is no weld. A solid bar will be extruded in the circular way, so there is no welded joints is needed. So it is called as a seamless pipe. With the weld joints, if it is called as the welded pipe. In the welded type, we can see EFW and ERW are the different types of welding technology. So the seamless, there is no welding is available. For the welded pipe, there are two technologies are there. One is EFW and another one is ERW. It's a different welded technologies. In the welded pipes, a plate or a rectangular plate will be bended and a circular shape will be formed. Once the circular shape will be formed, the two ends of the rectangular plate will be welded with the technology of EFW. Okay, so this is the manufacturing types of the pipe. Then but here I have considered the seamless pipe for the thickness calculation. Then the design pressure, it's 1400 pounds per square inch gauge. I have considered as my design pressure. This detail also available from line list. In the line list, that document was prepared by process discipline engineer. Then the design temperature, it's 600 Fahrenheit. I have considered this detail also available in the line list. Then the mechanical corrosion and erosion allowance of the pipe is 3 mm. It was suggested by the pipe process discipline engineer as a corrosion allowance. Then mill tolerance, it's only applicable for the seamless pipe. So I have considered 12.5% of mill tolerance in my calculations. Okay. For the welded pipes, mill tolerance won't become. Only for the seamless pipe, the mill tolerance will be come. It will be 12.5 percentage. This value also suggested by the process team. Now, as per ASME section B31.3 means in the ASME B31.3 code section 304.1.2, this is the formula we are using for pipe thickness calculations and under the internal pressure. Okay, this is the formula we are using. Here the T will be the calculated pipe thickness, which we are going to estimate the thickness. Then the P means internal design pressure, and then D is outside diameter of the pipe, and S is allowable stress value of the pipe material, E is quality factor for longitudinal well joints, and W is for well joint strength reduction factors. So the and Y is also there. Y is values of coefficient for T less than greater than D by 6. So these are all the factors we are following. Means this is the formula we are going to follow for the pipe wall thickness. This formula is available in section 304.1.2 in ASME B31.3. Okay. Now the next step, you have to define the design pressure. For this particular case, we have already considered the design pressure is 1400 psig, right? The outside diameter of the pipe, we have already estimated the diameter is 6 inch, means we have considered based on the P and ID. Then the allowable stress and the quality factor and well joint factor and Y. These values we need to refer from the 31.3 code book, where we need to refer. Those details we can see in the next slides. Okay, fine. We can get the outside diameter of the pipe first. We have considered 6-inch pipe over here, right? Now I am referring the ASME B36.1 for the CS pipe. If you are considering the stainless pipe, then you have to consider B36.19. Now I am considering for a carbon steel pipe. So you have to refer B36.10. In that 10, you can see the table number 1. Here you can search for the nominal pipe size. We have considered is 6 inch. Okay. So for a 6-inch pipe, the outside diameter is 168.3. Right. For all the pipe sizes in the nominal pipe size of 6 inch, the outside diameter will be same. The internal diameter will be different based on the wall thickness. Okay, so here I have considered the outside diameter is 168.3 mm. So this detail we can obtain from ASME B 36.10 for the carbon steel material, ASME B 36.19 for the stainless steel pipes. Okay. The second one, we need allowable stress value of the pipe. So for to get this value, here you can see in the formula. So allowable stress value, yes, we can extract from ASME B31.3 in the table number A1. Okay, in the table number A1, how we need to refer? First, here the temperature value is listed in the row wise in the top of the table. Okay, and then here the different type of materials in the carbon steel also categorized here. Now we are choosing A106 grade B material, and we have considered the temperature of 600. Okay, so 17.9 is the 9 KSI is the basic allowable stress value for this particular temperature and material considerations. So now I have choose 17.9, but the value is in KSI. So when I am considering this, I have to consider as PSI. So into 1000. So the value will be 17,900. It will be the value while I am considering the calculations. It will be coming in the next slides. Okay. So to get the allowable stress value, you have to refer ASME B 31.3 code book table A1. for to get the values, you need two inputs. One is the temperature limit, the another one is what kind of material you are going to use. With these two details, you can obtain the value of allowable stress in the ASME 31.3 code book. Then the third one is quality factor for longitudinal weld. This is called value E. Okay, this is also available in the code book ASME B31.3. Here you can just check for the A106 and the description is seamless pipe. Okay, so for the seamless pipe, the coefficient of means the quality factor is 1. So here we are going to consider the quality factor is 1 for A106 grade B material and for the seamless pipe. Okay, the next one. Now weld joint strength reduction factor, right? So W, to get these values, we need the material group. We are going to use the carbon steel and the temperature range. Now here we are using 600 Fahrenheit here. So it is here in this table you can get the value less than 800, less than or equal to 800. So we can consider this value as our weld joint strength reduction factor. This is also available in B31.3 table number 301, 302.3.5. In some cases, in the latest code book, the table numbers and things some may be differed because of new additions or deletions. Okay, so we have to follow the latest edition of the code book while we are considering while we are doing the design. Okay, and then the values of coefficient. Okay, this value is available in 31.3 code book, the table number 304.1.1. Here we have considered A106 grade B, right? So it's a ferritic steel. These detail how we can conclude if it is a ferritic or non-ferrous material, right? It will be available in ASME section 2. These detail is available in ASME section 2 material specification. There you can get if the material is ferritic or non-ferritic materials. Okay, so these kind of details you may get it from ASME section 2. Then if you are concluding if it is a ferritic steel, then you have to go for the temperature. Here 900 and below is the consideration. So I have considered my temperature is 600 degree Fahrenheit. For the ferritic material, the value of coefficient Y is 0.4. This is my consideration for the wall thickness calculations. Now I am going to perform the pipe wall thickness calculation. The T is equal to 1400 into 168.3, right? The 1400 is the pressure limit, design pressure I have considered, and 168.3 is the outer diameter of the pipe divided by 2 into 7900 is the allowable stress value, and 1 is quality factor and 1 is weld factor, plus 1400 is again the pressure into 0.4 is the coefficient factor. So with these formula, I have estimated the value. The required calculated thickness is 6.38 for my process conditions. So I have estimated the first things. This is the first calculation we have done. This is the first step of doing the selecting the selecting the pipe thickness. Then the second step, we need to add the corrosion or erosion allowance with the estimated thickness. It's calculated pipe wall thickness. Okay, so TC is equal to T plus C. Here TC, it stands for thickness with the corrosion allowance. So T is the estimated value plus 3 mm of corrosion allowance we have considered. So the calculated thickness with the corrosion allowance is 9.38 mm. This is the step 2. Now we are going for step 3. Okay, here we have considered the pipe as a seamless pipe, so the mill tolerance 12.5% we need to add. If it is a welded pipe, mill tolerance we can neglect. We can neglect the mill tolerance. If we are considering the seamless pipe, the 12.5% of mill tolerance will be considered. So Tm is equal to, with Tm is stands for thickness with mill tolerance. Okay, equal to Tc here, thickness with corrosion allowance plus 12.5% of mill tolerance seamless pipe. Okay, so here the formulas gives that mill tolerance is 10 point, the thickness with the mill tolerance is 10.72 millimeter. So this is the value we get it for the uh, particular process condition. It means 1400 psi of design pressure and 600 degree Fahrenheit of temperature. We arrive the thickness is 10.72 mm. Okay, then now 10.72 mm is the theoretical value based on our pressure limit and the temperature limit. But in the market, the same size won't be available. May be available if you, but most of the things, the theoretical and the market standard sizes will be different. Okay, so now we need to check for the nearest available thickness in the market. So for that, we are going to refer ASME B36.1. Yeah, it is for the steel pipe, means carbon steel pipe material and dimensional standard. In that particular standard, you may refer the same table, table number 1 for the 6-inch pipe. Okay, the available thicknesses are mentioned, wall thicknesses are mentioned over here, right? 7.92 mm is also available, 8.74 is available, 9.53 is available, and 10.97 is available. These are all the available thickness values in the market. So now we have estimated the value of 10.72 mm. Okay, so it will be in the range of between 10.97, nearest next value is 10.97. So for these particular process condition, we are choosing the piping with 10.97 wall thickness. This is the procedure to how to estimate the pipe wall thickness for one process condition. Okay, then now the uses of the extra thickness. Right now our record thickness is 10.72 mm, right? But we have added for 10.97, so around 0.25 mm of additional thickness we have provided. With that additional thickness, we can estimate the extra life of the pipe. So extra thickness we have considered is 0.25, and the corrosion per year, it was estimated 0.15. This detail will be given by the material engineer. Okay, based on these details, we have arrived the additional lifetime of the pipe is equal to 1.6 years, because we have designed this pipe for only 20 years. Right now, the additional 1.66 years also maybe the pipe will be in the service because of the considered extra thickness. Okay, and the maximum pressure holding capacity of the pipe, this is also will be different, because we have considered while doing the calculation the maximum pressure limit is 1400 psi, right? But right now we have considered some additional thickness. So in the same formula, we are getting P into the left hand side, getting T into the right hand side. If you are substituting over there, then you will get the maximum allowable working pressure value. So these 10.97 thickness can able to withstand around 1447 psig. Okay, before, but our design limit is 1400. So the pipe can withstand more than that 50 psig, around 50 psig the pipe can able to withstand. These are all the additional things and additional usage of the extra thickness we have considered. Okay, so this is the pictorial representation. Here you can see this is the internal diameter of the pipe. It's a cross sectional view. Okay, so it is the internal diameter of the pipe we have considered. Then MT is the mill tolerance, and CA is the corrosion allowance, ET is the extra thickness we have considered. Okay, so then T is the estimated thickness. So around this is the representation of the thickness we have considered right now. Fine. So as a piping engineer, we have to, we are well versed, and we need to familiarize with the things, how to estimate the pipe wall thickness, and then the piping material specification, how to refer the piping material specification to prepare the bill of quantities and material takeoff. So what is bill of quantity and material takeoff? Okay, while you are doing the design and engineering, after the completion of design and engineering, it means your piping network and piping systems is everything approved by the client. Then you are getting approval from the client for the construction. Okay, once your design is approved, then you going for the construction. In that construction time, you should know how much amount of quantity of pipe, or how much quantity of pipe fittings, how many walls we need to buy, in which sizes. So these are all the quantities we need for the particular project execution. Okay, so the details we need to, going for the purchase, we need the quantity. So to take the material to take the quantity of the material, the piping material specifications is the important one, because you need to mention the piping A106 grade B is a piping material, and what is the pipe class, 150 rating or 200 rating or 300 rating, 150 rating or 300 rating or 600 rating, what kind of pressure rating we are going to follow, and what kind of end connections it should be there, what kind of welding we should be follow for that particular piping connections, and everything we need to give as a specifications. Okay, these specifications are prepared by the piping material engineer, and it was reviewed by the piping design engineer also. Okay, these preparation of piping material specification in the part of material engineer, but however the piping engineer also should having the basic knowledge to refer, how to refer the piping material specifications. Okay, so this will give the most relevant details about the materials which we are going to procure. Okay, so the basic data record for the piping material specifications. So, which are all the fluids we are going to handle, and what are the all waste streams and the utility streams? What are the additives? So, these are all the major things. These details all will be provided by the piping process discipline engineers. Okay, to the material engineer. So the fluid characteristics and the waste streams characteristics, the utilities characteristics, and if any additional additives is going to be added, that additive characteristics. So all of the fluid and streams which we are coming under the project, those details will be provided by the process team to the piping material engineer. Okay, then based on the fluid characteristics and his based on his previous experiences and the codes and standards, he will choose the appropriate material for the piping design. Okay, then the toxic classification is the most important one, because if it is more toxic, the corrosive, it will be in the corrosive nature. Okay, so for that cases we need to consider more corrosion allowances, or some internal coating may be required. So for identification of the internal coating and the corrosion allowance, the toxic classification is more required. It will be also provided by the process engineering team. Then the operating pressure and the temperature of the particular service. So these temperature and pressure value also will be given by the process engineering team. So the corrosion rate for different pipe materials, based on the pipe materials, how much corrosions we need to follow. These details also provided by the process engineering team. Then the expected minimum and maximum pipe sizes. This detail will be available in the piping material specification based on the line list. In the line list, the process engineer will segregate all the line numbers with the pipe sizes. Okay, from that line list you can get the detail about what is the maximum size in the particular material we are going to follow, what will be the minimum size for the particular project we are going to follow. So all the details will be available in the line list. Based on that line list, we can extract the things for the maximum and minimum pipe size for the each material about to the project. Okay, then the locational and environmental conditions. Okay, so if you are going to install the pipe in the seashore or offshore platforms, the, the salt content in the air and atmospheric air will be more. So it will make some external corrosions also. It will make some external reactions also. To avoid that, we need to suggest for the multi-level painting, or for the in some areas we are suggesting for the insulations. Everything will be suggested, right? So to identify those kind of additional suggestions, we need the exact job site locations and the environmental condition of the site project location. These are the details we required to prepare the piping material specification. Okay. So in the piping material station specifications, what are the details we can extract? Okay. The first, in the piping class details, it will be give the project details, and as well as what is the revision number currently we following, what is the document number we are following, and who is the preparer, who is the reviewer, and who is the originator. So approval, those details are available in the initial introduction page. Then what are all the items are listed in the PMS? PMS means in the piping material specification, what are the items are listed? Those details also available. Then the pipe nominal size in inches or metric units. Okay. So what is the maximum from the minimum size to maximum size? All the nominal sizes are listed in that particular table. Then the wall thickness or pipe schedule. So estimated wall thickness and the ordered wall thickness. Here we can see the ordered available wall thickness as per the standard. So available wall thickness will be in the part of piping material specification. Then design limitation and the pressure temperature limits. This is also available in the piping material specifications. Then end connection type. What kind of end connections we should follow for the different services and the connections. For example, for the drain connections, what kind of ends we should follow. For the process lines, what kind of end connections we should follow. These are the details available in n connection types. Okay. Then the branch connection tables also, how we are going to take the branches from the piping lines. For example, we are going to reduce the branch. If 6-inch pipe is laying, if you want to take the 3-inch connections, you are going to use the reducing T, or you are going to use the reducers, or you are going to use any other weld outlets or sweep outlets. What kind of branch connections are available for the particular pipe sizes and based on the material. These details also available in the material specifications, and bolt and gasket details for the different types of flanges, and a short description of your piping component with the full purchase descriptions. Once you completed the project, then you will proceed for the material takeoff and the preparation of bill of quantity. In that bill of quantity, you should give one write up for each and every line item. For example, 6-inch carbon steel pipe with a pressure rating of 600 pound rating, seamless pipe. This is the description you are going to write, and the amount of meters means, for example, if you need that pipe for the 10 kilometer, then in the quantity you will add the quantity as 10 kilometer, right? That short descriptions is available in the piping material specifications. Once you prepare the BOQ document, and if you are issuing for the vendor to get the quotation in that time, with that BOQ, you should attach the PMS, piping material specification also. Then only he came to know what is the thickness they have followed, what is the details, what is the special additions they have followed, what kind of fittings they are going to use in the particular piping component. Everything they came to know. So while preparing, the PMS is the base document for the procurement and the designing as well. Okay. So then, before going to the piping engineering deliverables, I will show you one piping material specification document. I will open it separately. Okay. So this is one of the example piping material specifications. Here you can see Uh, Here they have described the PMS for the different pipe ratings: 150 pipe pound rating, 300 pound rating, and 600 pound rating. This is the piping class. This is called as the piping class. This 150 and 300 and 600. These are all related to the pressure limit of the particular piping system. Okay. Then the scope of the project is described, why the project is done. Then the codes and standards we have followed for this particular preparation of the piping material specification. It was described over here. Then the material specifications. For that material specification also, here they have means overquoted some piping standards. Then for the pipeline, it's for the pipeline we are not going to see here. Only for the piping only we are going to see. In the pipes, what are all the dimensional standards and the material standards we have followed. So all the details, the referred details means referred standard details are listed over here in the initial stages. The similar way for fittings, then the bends, then the flanges, gaskets, boltings and thread sealant, valves for each and every piping component. What are all the standards we are going to follow? All the details are listed in the initial few pages. Okay. Then for the piping material specification for bound rating 150. Here you can see first, they have listed the piping class. It's a 150 pressure rating piping class. Then the base material of the pipe is carbon steel. Then the corrosion allowance was already provided by the piping team. It's 1.5 process team. It was 1.5 millimeter. Then if there is any special requirement, so not for this one, so they have mentioned as non-IBR. Okay. Then temperature, it's minus 29 to 65 degrees Celsius. In our cases we have considered for around 600 degree Fahrenheit. However, this is the format to describe the piping class, the base material and the corrosion allowance. If there is any special requirement, then the temperature limit for the particular piping class, then the pressure limit also we need to mention over here. Okay. Then this pipe material is suitable for which services? So this pipe material they have suggested for non-corrosive process, okay, and flammable and non-flammable. For both the cases we can use that, but it should be the non-corrosive process. Okay, so non-corrosive fluids we should follow only applicable for these particular pipes. If it is corrosive, then you have to choose for the different pipe materials. Okay, so this is the things how we are going to choose the pipe material. Then hydrocarbons, ammonia, steam and gas condensate, utilities, instrument air, nitrogen, carbon dioxide and lube oil before the filter. For these all the services we can use this pipe material. Okay, here the special note is the non-corrosive process. So for the non-corrosive fluids we can use this pipe material. This is the information we are getting from this section. Then the welding details. Okay, so here what they have provided, all vents and drains shall be provided with gate valve with blind flange assembly and blind flange assembly unless otherwise indicated in P&ID. So all the vents and drains shall be within the gate valve. So this is a special note they have provided for this piping network. If they have provided for any provision specifically for the instruments, it should be with for the venting and drain connections, it should be with gate valve with a blind flange. Okay, so other special connections is as per the P&ID. If it is in the P&ID, they have specified any additional small bore connections or any cap instead of blind flange. If they have specifically mentioned in the blind P&ID, then it should be followed. Otherwise, for the vent and drains, they have to provide on gate valve and the blind flange. This is the note they have said. Then they have described about the radiography and the magnetical part inspection, magnetic particle inspection. Okay, so Here radiography is suggested for 100 percentage. After the welding the radiography is suggested. So radiography is one of the inspection method to get the healthiness of the welding what we have done. Okay, it will develop some profile like x-ray kind of profile they will develop. If the weld it is specifically done for the to check the healthiness of the weld joints. So 100 percentage radiography is suggested. So wherever you are doing the radio weldings for all the locations after the installations, you have to perform the radiography. And the MPI for the magnetic particle inspection also you need to done for all the socket welds. Where you have done the socket welds for all the locations, you need to perform the magnetic particle inspections. Then what they have suggested, the piping design as per ASME 31.8 and OASD 141. So I think this will be developed for one gas transmission line. So for the gas transmission they have specified 31.8 and OSD 141. These are the piping design standard categories they have suggested. Then flanges of size 22 inch shall be as per MSS SP 44. So it's a manufacturer means manufacturer standard specifications. So this is the standard we should follow for the flange manufacturing. So for the flange manufacturing, what is the standard we should follow, that detail also they have incorporated here. Then Sharpie V-notch test and harness test shall be conducted for pipe fittings and flanges. These are the vendor related testings. So Sharpie V-notch test and the harness test for the pipe and the pipe fittings should be performed by the vendor. While they have delivered the product, they should do these factory acceptance test. In that factory acceptance test, Sharpie V-notch and harness test should be performed. In the presence of the particular client representative. Okay, then all the branch connections including vent, drain, pressure and temperature connection shall be as well as the branch connection table given in the next page. So in the next page they have provided how to take the branch for each branch connections, like to take the venting, to take the draining, to take the instruments, how we are going to proceed for the branch connections. Here you can see the run pipe size in the first row, right, in the bottom row. Here you can see the 0.5 is half an inch, 0.7 is 3 by 4 inch, and it's 1 inch, it's 1 1/4 inch and 1 1/2 inch. In the similar way, the run pipe size is mentioned over here. Okay, it's a main pipe. It's a main pipe. If you are taking any branch in the vertical way or in the horizontal way, so the branch connection pipe size mentioned in the column wise. Okay, not in the, it is in the row way. Okay, here I will write something and you can get. So this is the main pipe. This size is mentioned over here. It may be 2 inch, it may be 3 inch, it may be 4 inch, however, based on the main pipe size. And then this is the branch connection we are going to take. So this pipe size may be 2 inch or 3 inch or 4 inch or means something, some whatever it is as per the P&ID. Okay. Now, for example, if I am taking one 2-inch pipe is a main run pipe and I'm going to take a branch of 2 inch, then I have to go over here 2 and here 2. Here they have suggested the connection is T, right? So the T is the fitting they have suggested to take the branch is T joint. Okay. Then for example, here they have suggested as yes also, right? One second. Here the description of all the branch fittings is they have specified. If it is T, then it will be T. If it is W, it for weld outlet. In the similar way, if it is L for sweep outlet, this is the legend they have followed for the branch connection table. Okay, if it is P, it's for pipe to pipe. We can directly weld one pipe to another. So these are all the details. We can get it over here based on the run pipe size and the branch pipe size. So these are all the available branch connection table. This detail also available in the piping material specification. Then there are multiple pipe groups are there for the lower size to higher size. For each pipe, what is the material we should follow, what is the dimension standard, what is the scheduled thickness. So these are all the details based on the project requirement they have categorized over there. For the pipes, for the flanges, for each and everything they have listed the lower size to upper size, the thickness requirement, dimensional standards, material, and in the description they have specified PE and seamless, right? So they here they have followed going for followed for the PE means plain end. Okay, plain end and bevel end. There are multiple ending in the piping services. In the plain end means the end surface of the pipe will be the flat end. Okay, if it is in the bevel end, the end surface of the pipeline somehow between the bevel in some angle. Okay, some angular finish may be available in the pipe. So that kind of description they have provided over here. So that is plain and seamless pipe. It is a description. Then the material is A0, A106 grade B, and the dimension standard is ASME B36.10, and the scheduled thickness is S160. Or instead of 160, you can maybe put the SI standard also. In the millimeter also, you can specify the thickness. And these two are all the lower size and the upper size of the pipes which we are going to follow for the particular project execution. In the similar way, only not only for the pipe, for the flanges, for the each and every fittings, all the details will be available in the piping material specifications for all the piping classes. Okay, so this is the sample document which I want to show you. That's why I have presented over here. Now I going back to the presentation. Okay. In an organization, how the piping engineering discipline will be work. Okay. So for each and every engineering consultancy in the medium or large scale, if anyhow, there is one piping department manager. He will be there. Okay. Under his guidance, the piping lead engineers will be working for the assigned projects. Okay. Under each piping lead engineer means he is a direct assistant for the piping department manager. Under his direct control, there are multiple discipline engineers will be there. One is for the piping material engineer, another one for piping layout and design engineer, lead piping stress engineer, and lead piping pipe support engineer. Okay, so these are the different categories of lead discipline, different categories of piping discipline activities over the engineering consultancy. So these are all specialized departments. Okay, the piping material department will prepare piping material specification and other testing and inspection specifications and material requisitions. So a lot of engineering deliverables was prepared by the material engineer. They will be in the direct coordinate with process engineers to choose the correct pipe materials and the fitting materials. Okay, and the piping layout and design. These are the common engineering discipline, because the layout preparation and the design of 3D modeling of the particular piping and everything related to the drawings and the related to the purchase and procurement is coming under piping layout and design engineers. So under his late piping design engineers, maybe the piping designers and draftsmen will be available, and 3D modeling department also available. Okay, they are all working under lead piping layout and design engineer. Then lead piping stress engineer also there. The stress engineer's work is need to study the identified stress elements, because for each and every project, the piping lead engineers will categorize the critical pipeline list for each and every project. They will develop one document. The document name is called critical pipeline list. Okay, in that critical line list they have categorized some line numbers uh, based on the severity of the stress and load, means stress and load problems. Okay, once they have identified the critical line list, then the piping stress engineer will design the same pipeline in the stress analysis software, and they will estimate the load values and the allowable stress values. If the stress value is within allowable limit, then it is fine. If it is exceeding the allowable limit, then we need to do some minor modifications or the major modifications in the piping network to accommodate the allowable stress value within the allowable limit. That is the important role of the stress engineer. They will doing the analysis and giving suggestions to improve the stress analyzing activity for the each stress analysis, stress accommodation property of each piping network. Then once the stress engineer is completing his job, he will give some suggestions to the support engineer. Okay, so the lead piping support engineer will design the appropriate piping support to make the piping network in the stable way. Okay, so the piping support and the piping stress engineer is having some close coordinations while they are doing the piping design. So this is the overall organization setup in the piping engineering discipline. Okay, now we are going to see the major engineering deliverables which we are developing in the engineering stage. Here I have listed plot plans, equipment layout, piping general arrangement drawing, piping section and details drawing, conceptual piping layouts and study piping layouts, piping isometrics drawings, line designation table, tie-in schedule, last orientation drawings, piping demolition drawings, pipe support drawings, material takeoff or bill of quantity, piping material classes, piping specifications, specialty item list, data sheets for valves, data sheet for piping specials, and then we will perform for the TBE and piping stress levels report as well as a 3D piping model. These are all of the major piping engineering deliverables for preparation of any kind of engineering projects. Uh, I think someone's mic is on. So I think I have covered all the things from my side. Uh, Anupama?
Yes, Ashwin, thank you so much for such a great session. So we'll take the questions quickly.
Sure.
Also, I've shared the attendance link in the chat. You can mark attendance. First question, what is the basis for preparing branch table?
Okay. So to prepare the branch table, the piping material engineer will study the codes. The first of all the codes. Okay, in the ASME section 2, for each and every material, the stableness of drilling and other operations, how much stress it can be withstand, how much elasticity value and how much n smallest value is there for each and every materials. They are giving some mechanical properties while you are doing the external operations in that particular materials. Okay, so based on that details, they will suggest if you are making the pipe to pipe weld, or if you are going for the branch with the T. If you are for example, you consider the pipe thickness value is 10 mm. For example, I have said if it is 10 mm, and the connection pipe thickness also in 10 mm, so the weight of the connecting pipe will going to be act in the surface of the run pipe, right? So those details will determine this weight can be accommodated by the run pipe or not. So that thickness, if will not make any defects on the running pipe, then we can go ahead for the pipe to pipe weld. If anything will happen, if anything happened on the piping surface, based on our previous experiences and previous project experience and the researchers, they know about the material capability. So if the thickness is not accommodated for getting the new pipe, then we are going for the fitting. Usually the thickness of the fittings is slightly higher than the pipes. So that's why, that is the thing, that is a base idea to prepare the branch table based on the standards.
Okay, and next question. Can you explain about PMS creation? How to select and select end connections and yeah,
Okay.
can you, yeah.
Okay. So the end connections means if they have asked for the, I think so, the blind flanges and the cap and the threaded fittings. There are multiple types of fittings are there to do the end connections, to perform the end connections. Okay, it's based on the pressure rating and the process requirement. Okay, in some cases, the process team will guide us to give the blind flanges in the end. Okay, so if they have suggested to go ahead with the blind flanges, then we will provide the blind flanges for that particular end connections. If they have suggested to go with the cap, then we will provide for the caps. Even in some cases, they will suggest to go ahead with the threaded flanges. Okay, so threaded fittings means the threaded caps or threaded blinds. In that time, we will go ahead with the threaded and blinded flange. So there is no specific rule from the piping side. It was suggested by the process discipline in the PNID. It's based on the aircraft.
Okay, next question. Can you explain the relation between toxic classification and piping selection?
Toxic.
Classification and piping selection.
Okay, toxic classification and piping selection. So this is a specific discipline query because the piping material engineer will have the direct contact with the process team. The process engineering team will develop the stream numbers, and for under that stream number, each and every fluid characteristics will be there. Okay, among those, if the fluid has the amine quantity, amine or any other sulfide quantities, so these are all the toxic elements, right? Major toxic elements. If the toxic elements is was high in the fluid characteristics, then they will inform to the piping material engineering team. Piping material engineering team, not for the design team. The piping material engineers, what they will do is they will have a look on their previous records and the standards, which are the material can able to withstand that particular means not reacted with that particular fluid. That is the first case they will do. Okay, so the reaction coordination they will do. And again, if for example, if you go ahead with the stainless steel, the stainless steel cost is too high. So to reduce the cost, what are the alternative methods? So they go ahead with that ideology. If there is any internal coating is available, if there is internal coating we have provided, if we can avoid that problem, then they will do the chance for that also. Okay, in this way only, in the R&D, it's just the research and development way also. Okay, so they are doing the repeated things, and they have the reference of previous project experience. Based on that experience only, they will choose the material with related to the toxic identification.
Okay. What is plane end mass mentioned in the ASME table? Plane end mass.
ASME.
What is plane end mass that is mentioned in the ASME table?
End mass.
Yeah, that's the question. Yeah.
I'm not sure about that. End mass means
Okay, we'll move
where.
on to the next question. Ashwin, you're not sure.
Okay.
How do we choose pound rating in PMS?
Pound rating. It's a
Yeah.
150 rating. Yeah, okay. Usually, the 150 rating can able to withstand 17.2 bar G. Okay, the 17.2 to 17.5. I'm not sure about the value, but it's inter between the 17 to 18 bar G. Okay, so based on the internal pressure requirement of the pipe, we will choose the 150 class rating. There are two main standards. One is American standards, another one is European standards. Okay, which are all following overall the world. Okay, in the American standards, we describe the pressure rating in the rating, pound rating, 150 rating or 300 rating or 600 rating in the similar way. It is just an identification of the internal pressure capability. Okay, it's just a representation. Then in if you are going for the European standards, they will give the number called PN number. PN20, PN40, PN60. So that PN20 is equal to it can be withstand up to 10 20 bar g of internal pressure. It is the thing. In that 150 pound rating also, it's a piping class, it can be withstand up to 17 bar G. So there is one table in the ASME sections. In the table, for each and every material, they have listed as per the piping classes how much maximum internal pressure that material can, that pipe can be withstand. These are the details listed in the ASME table. Please refer the table to get the exact details. Okay.
Okay, next question. How do we decide the dimension and other requirements of non-standard piping specialty items? Is there any specific standard for this?
No, there is no specific standards. If you are going for the non-standard fittings, there are multiple guidelines will be followed. For example, if you say after the designing of a non-standard fitting, you have to perform the finite element analysis. Okay, to means to prove its mechanical stability and other load capabilities, to prove that all the mechanical qualities which demands the codes. Okay, the load testing or the means the stress analysis capability, to all the mechanical properties we need to prove to the codes. Okay, so for that performation we will perform, once we complete the 3D modeling, then we will give that particular model to the finite element analysis team. They will perform some finite element analysis and give the maximum load bearing capacity and maximum stress analyzing capacity, and they have given some standard templates to us. Once if the values are okay for the project requirement, then we will go ahead for the special fittings. If it is not meet the requirement, then we choose for the alternative options. These are the things.
Okay. Difference between tie-in joint and golden joint.
Sorry.
Difference between tie-in joint and golden joint.
Golden joints. No, tie-in points. Maybe he is asking for the tie-in junctions, I think. Okay. So if you are handling with the existing facility, for example, if you have any running plant with you, okay, and you are going to connect, introduce one new piping in it, in that time, where you are going to connect that particular pipe. Okay, if there is any external existing provision is there, if there is no provision, you need to introduce one new provision, right? So these kind of tie-ins will be identified in the site conditions while you are doing the site survey. Okay, if you are you have to do the feasibility to take the tie-in in the site conditions. Once you identify the locations, then you need to develop the drawings and get the confirmation from the safety and maintenance teams and the operations teams. Once they have give the approval, then you can take the tie-in. Okay, so the tie-in means the existing plant or the existing running plants are going to introduce one new pipe, or otherwise you are going to demolish something in new. You need to give the isolations, and then you need to take the new piping connections. So these are all the things. This the tie-in is not only the terminology we are going to demolish or we are going to introduce. It's just the isolation, then getting this, analyzing the safety operations, then you proceed for the new demolition and you proceed for the new constructions. So these are all the terms. It's coming under that one tie-in schedule or the tie-in philosophy.
Okay. Which table we need to refer to finalize pound rating and PMS?
to pound rating of the PMS means it's confusing because in the PMS in the standard we have 150 pound rating, 300 pound rating, 600 pound rating, and 900 pound rating. Okay, these are all the pound rating values already done the means done the researches and done the testing for the particular piping materials by the American ASTM means AST Society of Testing Materials. They have performed many tests for the particular material. Once you introduced one new material, then that testing team will perform multiple mechanical testing and other mechanical property testing with the help of equipments. Then they will categorize all the details in the ASME section 8 for the under each and every material grade number. Okay, in that material grade number they will tell if we are with that material, if you are making the pipe or other things, they will develop one individual standard. In that standard is called ASME B36.11. Okay, in that number for the carbon steel pipes, I have said for the carbon steel pipes ASME 36.11 and ASME 36.19 for the stainless steel pipes. Okay, only for the pipes I have said. In the pipe table means what are the maximum allowable pressure limit for the piping with the various thicknesses. Okay, if the thickness is 6 mm, what is the maximum allowable pressure it can be withstand. In the similar way, if it is 150 rating, the thickness range will be different. If it is 300 rating, the thickness range will be different. Based on the thicknesses value, the allowable stress value is defined in the ASME section ASME B 36.11. In that, for the each and every material, there we can refer the values. If not available on tomorrow's session, I think on Tuesday section, I will ask Mr. Chandramohan to present that also. Okay, he will give the table values where we have to exactly refer that values or the PMS pound rating.
Difference between MWP and MAWP.
Okay, maximum work pressure and maximum allowable work pressure. It's different for the pressure vessels. Not okay. Um, For example, you consider one pipeline or one piping. The process limitation is 80 bar G. Okay, it is the operating conditions. Now we are going to consider if a pipe is 1.25 times of the design or 1.5 times of the design. So 80 here we can go ahead with the 1.5 times. So 1.5 times into 80 is 120 bar G is a design case. So the maximum working pressure is 80 bar G means 120 bar G. The operating pressure is 80 bar G. Okay, this is the case. Then the 120 is maximum working pressure. It's a design pressure, and the maximum working pressure is almost same. It's the same. Okay. Then the maximum allowable working pressure during some surge cases if you are performing some surge analysis for the piping network, they will give some additional percentage means to withstand the surge, because the surge analysis or the surge effect may be happen for the few seconds or few minutes. It's based on the scenarios. Okay, this is the different way. That is a different operational case. The surge may be happen. There are many root causes for to happen the surge analysis in the piping systems. If in case a surge has happened, in that time we can consider 1.1 to 1.2 times of maximum allowable pressure, means maximum working pressure limit. If it is 120 bar is a maximum working pressure, we can consider 1.1 into 1.2 times of the maximum working pressure is a maximum allowing pressure. Okay, allowing working pressure. So MWP is equal to 1.1 to 1.2 times of MAWP. Okay, so this is the case, but it's only for the surge analysis cases, not for all cases. Okay.
What are the different considerations for low and high temperature service pipings?
I'm not sure. Sorry.
What are the different considerations for low and high temperature service piping?
Okay, for the low and high temperature service piping, you can consider CS pipe. Okay, in the CS pipe, there are two categories. In today's presentation itself, I have presented. One is carbon steel, normal carbon steel. Another one is low temperature carbon steel. Correct. So both are the alloy steels with use of the low temperature carbon steels with make of additional nickel as a alloy material. Okay, so the capability of the materials, the temperature withstanding depends on the chemical properties of this, means mechanical composition of the particular material. Okay, how much percentage of carbon is there, how much percentage of iron is there, how much percentage of nickel is there. So these are all the these are all the base to measure its maximum withstand against the temperature. Okay, so these are the purely related to the material part. It's not related to the piping, but the choosing the material based on the temperature by help of PMS. In the PMS, in the piping material specification, the material engineer will give the details. What is the lowest temperature this material can withstand? What is the highest material temperature this material can withstand? These details are analyzed and given by the piping material engineer, and it's recorded in the PMS. So once we are, as a piping engineer, if I'm referring the PMS, I can able to get the values. So if I'm choosing A106 grade B, its temperature limit will be minus 20 degrees Celsius to maximum up to 600 degrees Celsius in this range. So the minus 20 is the lowest temperature point, and that 600 is the maximum allowable temperature for this particular material. If your temperature is not falling under, if you're operating or if your process temperature it's not falling under this category, then you go ahead for the different material to withstand that property.
Can you explain about reinforced pad thickness calculation?
It's a separate reinforced pad thickness. It's a means it's a separate section. We need, I think, in the section stress analysis sessions also planned, Mr. Anupama, right?
1 second now.
Yeah, stress analysis also planned.
Yeah, stress analysis is planned. Yeah, we have the upcoming session. Yeah, we have.
Yes, in that upcoming section, they will clearly explain about the reinforcement pad calculations and how the thickness is estimated. Everything they will develop and they will give you the explanation in that.
Okay. Do you have any more questions? You can just unmute yourself and ask. We have exceeded the time actually. If you have questions, you can unmute and ask. Any more questions, anybody? Which I haven't addressed. Anyone wants to ask me questions? Yes, please ask, Shankara.
Sir, whether the codes are standard for all the organization or it may vary for every organization?
Sorry?
Sir, you first explained the codes, sir, codes and standards.
ஆமா தமிழ் தானா?
ஆமா சார், ஆமா சார்.
கேளுங்க.
சார், அந்த கோர்ஸ்ன்றது வந்து ஒரு ஆர்கனைசேஷனுக்கு ஒரு மாதிரி இல்ல எல்லா ஆர்கனைசேஷனும் காமனா இருக்குமா இல்ல ஒவ்வொரு ஆர்கனைசேஷனுக்கும் ஒவ்வொரு மாதிரி இருக்கு?
இல்ல கோட்ஸ் அண்ட் ஸ்டாண்டர்ட்ஸ்ங்கிறது வந்து எல்லா ஆர்கனைசேஷனுக்கும் காமன் தான். இப்போ இன்டர்நேஷனல் நீங்க ஆர்கனைசேஷன் கேட்கறது கம்பெனிஸை வச்சு கேட்குறீங்களா இல்ல அந்த ஏபி ஆர்கனைசேஷன் அந்த மாதிரி கேட்குறீங்கன்னு எனக்கு தெரியல.
இல்ல சார், கம்பெனிஸ்.
ஓகே, ஸோ எல்லா கம்பெனிஸுமே இந்த கோட்ஸ் அண்ட் ஸ்டாண்டர்ட்ஸ் அப்படிங்கிறத டிஃபைன் பண்ணதுன்னு பார்த்தீங்கன்னா, இப்போ ஏஎஸ்டிஎம்னு சொல்லிட்டு ஒரு ஆர்கனைசேஷன் இருக்கு, ஓகேவா? ஏபிஐன்னு சொல்லிட்டு ஒரு ஆர்கனைசேஷன் இருக்கு. அவங்களாம் இன்ஸ்டிடியூட்ஸ். அந்த இன்ஸ்டிடியூட்ல யாரெல்லாம் மெம்பரா இருப்பாங்க அப்படின்னு நீங்க பாத்தீங்கன்னா, வேர்ல்ட்ல இருக்கிற பிக் கம்பெனிஸோட இன்ஜினியர்ஸ் இருப்பாங்க, அடுத்து மேனுஃபேக்சரிங் யூனிட்ஸோட இன்ஜினியர்ஸ் இருப்பாங்க, அடுத்து டெஸ்டிங் அண்ட் இன்ஸ்பெக்ஷன் சேஃப்டி ஆஃபீஸர்ஸ் எல்லாருமே அதுல வந்து மெம்பர்ஷிப்பா இருப்பாங்க, ஓகேவா? அந்த இன்ஜினியர்ஸ் எல்லாம் ஒன்னா சேர்ந்து ரிசர்ச் பண்ணும்போது இல்ல அவங்களோட ப்ரீவியஸ் எக்ஸ்பீரியன்சஸ்ல அவங்க ஃபைண்ட் பண்ணது இது எல்லாத்தையுமே வச்சுதான் அந்த கோட்ஸ் அண்ட் ஸ்டாண்டர்ட்ஸை ப்ரிப்பேர் பண்ணியிருப்பாங்க. ஸோ சேஃப் ஆப்ரேஷன் பண்றதுக்கு உங்களுக்கு என்ன மாதிரியான ரூல்ஸ் எல்லாம் ஃபாலோ பண்ணா உங்களால சேஃபா ஒரு பிளான்ட்டை ரன் பண்ண முடியும், இல்ல சேஃபா ஒரு டிசைன் பண்ண முடியும், இந்த டீடைல்ஸ் எல்லாம் அவங்க மீன்ஸ் ஒரு செட் ஆஃப் குரூப் ஆஃப் இன்ஜினியர்ஸ் வந்து ப்ரிப்பேர் பண்ணியிருப்பாங்க. அந்த ப்ரிப்பரேஷன் டாக்குமெண்ட்ஸ் தான் கோட்ஸ் அண்ட் ஸ்டாண்டர்ட்ஸ். இது வேர்ல்ட் லெவல்ல நீங்க எங்க போனாலும், அமெரிக்கன் ஸ்டாண்டர்ட்ஸ் போனாலும் சரி, இல்ல யூரோப்பியன் ஸ்டாண்டர்ட்ஸ் போனாலும் சரி, இல்ல ஜப்பானீஸ் ஸ்டாண்டர்ட்ஸ் போனாலும் சரி, எந்த ஸ்டாண்டர்ட்ஸ் போனாலும் கோட்ஸ்ல சொன்ன வேல்யூஸ் எதுவும் மாறாது. அந்த ஸ்டேட்மெண்ட்ஸ் கொஞ்சம் முன்ன பின்ன டிஃபரெண்ட் ஆகுமே தவிர மற்றபடி எல்லா டீட்டெயில்ஸுமே கிட்டத்தட்ட சிமிலர் தான்.
Any more questions? If there's no question, we can wind up the session. Ashwin, I think there's no more questions. We can wind up the session. Thank you so much for taking time and doing this session. And also all participants, thank you for your active interaction. Thank you.